Good morning, everyone, or afternoon, depending where you are. Peter Newman with you, and welcome to another Weed Smart webinar. Today we have Peter Boutsalis giving us an update on glyphosate resistance. How are you, Pete?
Really good at the moment. A bit cold in my office, but lovely otherwise.
Yeah, working from the home office, I see, or?
Just today. It's my wife's office. I've only got a kitchen table, but she lets me use it sometimes.
Oh, that's good of her. Excellent. Look, I'll hand over to you in a minute, Pete. Just we won't waste much time with housekeeping because we know that you're all experts in Zoom and video conferences and so on these days, but always like to show what's going on with WeedSmart and always like to highlight our WeedSmart partners and contributors. So all those people, all those companies and organisations above the red line on the right there, they are our financial contributors, and below the line are our in-kind partners. So WeedSmart's going from strength to strength. We've had increases in funding from a lot of these people, and particularly GRDC have upped their stake. And the WeedSmart program is locked in for a few more years and going really well financially, and we're able to bring you lots of good information, including Peter Boutsalis today. So, Pete, I'll let you take over the screen share.
Yep.
This year, New South Wales and other parts of the East Coast had a good start to the season, which meant that you probably saw a good opportunity for a knockdown, which hasn't really been around for the last few years. And I'm guessing because of that knockdown opportunity and those good rains, we saw a lot more glyphosate resistance. And
Absolutely.
I'm certainly hearing that from Greg Condon and other farmers in that part of the world. And yeah, so you're going to tell us a little bit about that and give us an update on glyphosate resistance and maybe a few tricks about how to get the best out of glyphosate
Sure.
in these times.
Will do.
Share screen and hand over to you. I'll give you a moment to do that.
Okay.
I just said we're experts in Zoom, mate. You can't be messing it up now.
10 second delay. And away we go, I reckon.
And just before Pete starts off, get your questions into the Q&A box. I'll keep an eye on that and I'll interject from time to time and let Pete know that there's a question in.
Cool. Very good. Welcome everyone. Good morning, good afternoon. I'll present today a little bit of information on glyphosate, optimizing glyphosate, and also glyphosate resistance update. As Pete said, there's been a lot of rain in the Eastern Australia. We still need a lot more rain because our crops are very healthy at the moment, but they're getting a little bit thirsty, I reckon. But early on, it gave us the opportunity to spray a lot of glyphosate knockdowns, and very early on, prior to sowing, and I have obtained or received a lot of quick tests, a lot of plant samples coming from New South Wales, SA and Vic, especially, testing for glyphosate resistance and also different rates of glyphosate. And I've just got some data here. I've just managed to pencil it in. But while we've so far tested 106 samples of ryegrass for glyphosate, and of those, 13 have come from WA, 24 from SA, 31 from Victoria, and 39 from New South Wales. And of those, we've got from WA, 62% of those samples have shown resistance to glyphosate, 46% from SA, so almost 50%, so half of those samples resistant to glyphosate, 65% from Victoria has shown resistant to glyphosate, and 87% of the 39 samples we received from New South Wales shown resistance to glyphosate. Increasing the rate sometimes has worked, other times it's had little impact at all. Some of the farmers have said that, we haven't sprayed glyphosate for a little while. Why have got this resistance? Where's it come from? There have been some flooding events, and we believe that there's been seed moving in via floodwater as well. So that's one way to get glyphosate resistance. Bit of a concern, actually. I hadn't realised that because we don't get a lot of flooding here in SA. Glyphosate's been around for a lot of years, since the 1970s. First known as Roundup, and now there's over 600 products available, although you can't easily access 600 products, but there are 600 registrations in Australia. Resistance was first confirmed in 1996 in an orchard, And to date, I reckon there's probably about 20 species that's even becoming a bit old, the information. So we're starting to see the latest couple species. We're still trying to confirm. That's a Salvation Jane from cotton fields, and also perennial ryegrass from vineyards as well. So, and out there's lots of cases. So what's causing resistance? Ryegrass has a very genetic background. You've probably heard this many times before, but there's a lot of different genes around. Now, reduced rates. When glyphosate first came onto the market, our ryegrass was susceptible. Farmers quickly realized that cutting rates, because it was very expensive back then, resulted in excellent control. However, there were guys there surviving in the background, unnoticed resistance. We hadn't heard about resistance. We weren't aware of it. And they were cross-pollinating, accumulating those different resistance mechanisms, and slowly but surely increasing the levels of resistance to what we have today. So it's been a slow accumulation of those mechanisms. And they're all very different mechanisms. So very subtle differences, but still they stack and they produce high levels of resistance when it happens over a lot of time. More recently, low quality products and low quality surfactants. So you're putting out the field rate, but the ryegrass isn't receiving that, especially if there's some kind of stress out there, then the weaker these lower quality products just aren't doing the job. In combination with stressed weeds, spraying larger plants, and also poor application. So when you start to put two or three of these factors together, it can become you can have quite a dirty job. So ryegrass has we've identified 3 different distinct mechanisms, but there are a lot of variations of these. Ryegrass is unique. It has a sequestration mechanism, and that is the glyphosate is absorbed by the plant as per normal, but a lot of it is moved away into areas of the plant like leaf tips, which haven't got a lot of meristematic activity. The more glyphosate you put, you start to overrun the transport system of the plant, and finally you get a lot of glyphosate getting down to that zone, the meristematic zone near ground level, and causing resistance. Windmill grass, brome, barley grass, and barnyard grass have got an increased expression of the target enzyme. So glyphosate inhibits one enzyme, EPSP synthase. Now, when the glyphosate binds, inactivates the enzyme, the plant dies, starves to death. But if you've got 50 times that concentration, you've got lots of enzyme left over to actually increase the plant, help it grow. So that's it's like a tumor. If you think of it like a cancer or a tumor, that's what these things do, and they produce a lot of the target enzyme, the EPSP synthase. Sow thistle, feathertop rosegrass, and ryegrass have a target site mechanism as well. So you're familiar with Group A and Group B target site resistance. Well, we've also got target site resistance to glyphosate, but unlike Group A and Group B resistance, the Group M target site resistance, so glyphosate target site resistance causes very weak resistance. So a lot of our ryegrass that have this mechanism are easily killed by increasing the rate by 2 or 3-fold. So they're the 3 distinct mechanisms that the species have evolved so far. When they start to cross-pollinate, so if you've got 2 or 3 of these species, or if you've got 2 individuals with a different mechanism and they're next to each other, they'll cross-pollinate, accumulate both of those mechanisms, and the progeny will be much more resistant. Don't think that each individual mechanism, in one paddock, you've got one mechanism. There are different mechanisms within a paddock, and so that can cause the complex movement of sensitivity to glyphosate. In our part, WA surveys have showed, the last surveys I'd seen, that about 1% of the glyphosate resistance had been detected by the random weed surveys. Over in SA, Vic, and New South Wales, we've been doing more localised surveys in regions and revisiting these regions every 5 years. And what we've found is that if you look at all of SA, about 4% is glyphosate resistant. So 4% of the ryegrass we collect from paddocks is glyphosate resistant, 3% from New South Wales, and 4% from Victoria. But if we then go into smaller regions, like the southeast of South Australia, here we detected about 7 years ago 17% resistance, which 5 years later, so a couple of years ago, it had increased to 27. So more than a quarter of the ryegrass we collected from this random weed survey was glyphosate resistant. More recently, last year, we surveyed southern Victoria. This surprised us because 5 years prior, we had detected 4% resistance, and it's gone up by tenfold in 5 years to 40% resistance. So large increase, but it doesn't mean that the actual 40% of the paddocks were infested with glyphosate resistant ryegrass. Often there weren't a lot of plants in there. So they were the ones that had escaped throughout the season, but most of the others had been killed. But nevertheless, it's important to know that there are glyphosate resistant plants in that paddock, and that's a worry. So how can we get the most out of better control with glyphosate? So this is a bit of a summary slide. Weed growth stage, we know that young plants are more sensitive than old plants. Glyphosate doesn't have to move as far. The cuticles are thinner. It enters much easier, so you get much better activity than older plants. Even if they're resistant, they can be killed or seriously damaged if you target them at the 3 or 4 leaf stage rather than letting them produce a few tillers. Water quality is very important. We'll go through this. Glyphosate binds to positive ions, so magnesium or calcium in the water, and sediments out. Water volume, so water volume's around 80 litres is optimum, and that's where I think most of you guys are at. If you're too low or too high, you can get a dilution of the loaded products, because loaded products are set for about 80 to 100 litres. If you have a nice concentrated droplet, you have a nice large concentration gradient which can transfer quite rapidly across a leaf surface, versus if you've got a lot of dispersed micro droplets which also dehydrate dry very easily. And once the herbicide is dry on the leaf surface, there's no more activity, there's no more uptake. In the past, like in a 2,000 hectare farm, I've been in presentations where farmers said, oh no, we're cutting costs. And I did some basic mathematics, and the difference between often a low quality product and a high quality product is often around $1 a hectare. And that's $2,000 over a 2,000 hectare farm. That is, I reckon, a pretty low cost, $2,000, to ensure that you get much better control. So this is just the Ultramax label, and I'm not going to read it all, but it's got there that their optimized concentration is 80 litres per hectare. Okay, nice and concentrated droplets to maximize the uptake. You don't want to dilute the surfactant that's in there by using high rates. Growth stages. Here we've got a trial that I conducted some trials to show that spraying larger plants is not as effective with glyphosate. So here we've got a susceptible population, and we had various growth stages. And what I found was that if you apply glyphosate under optimum conditions, even if they're large plants and healthy, they are killed. But what we found, what we weren't expecting, even though it's quite a well-known phenomenon, is that when we applied the glyphosate on one-leaf plants, we had a lot of survival. And the reason there is because at that stage, the growing seedling is still getting energy resources from that little seed, and all the movement is moving up. And so glyphosate's not moving down, and we had survival. So going at that one-leaf stage is a big no-no. We couldn't even get control in pots under perfect spraying conditions. So a little bit of a surprise for us there. Are all glyphosate products the same? Here we have 6 different products going from top to bottom, sprayed with the same 500 grams active glyphosate, so about recommended rate. On the left-hand side, the single pot is the untreated. So the pots on the top are glyphosate susceptible, and the pots on the bottom are glyphosate resistant. And the top left and the bottom left are the same products. So you can see that moving left to right, there are some pots, and through the 3 pot groups are replicates of, so there's three pots of the same population sprayed with the same herbicide. So you can see that there's a variation there, and they're the same amount of glyphosate, the difference being it's the surfactant package that's included. The ones on the right was the weakest glyphosate, both on susceptible on the top and the resistant ones down the bottom. So on the right hand side of the bottom photo, you can see there's a lot of survival there, whereas some of those other products were much better on glyphosate resistant ryegrass. So there are differences. There are clear distinct differences due to surfactant.
So Pete, those ones on the right, did they get wetter added, I imagine? Just normal wet?
No, because it was the loaded products, there was no loaded. Okay. There was no wetter. Yeah, whatever was in the actual product. Yeah. So we were testing loaded products.
Thank you.
And here we have 3 different species. So prickly lettuce, fleabane, and feathertop Rhodes grass. We've got 3 glyphosate products in red, in green, and in dark grey. And you can see at lower rates, there are large differences between control of the various species. And as you increase the rate, the differences go, and at very high rates, there are no differences. So if you spray really high rates of glyphosate, you can spray a lower quality product, it's okay. If you spray 5-6 litres, it'll still work. But at those field rates, there are significant differences. And some glyphosates, what we're starting to get a feeling, are better than others. So we know something that the 510 products is about a dozen 510 glyphosates registered on the PubChris, on the registration site there. The 510s don't seem to be controlling glyphosate as well as the other glyphosates, but they do work better on other species. So you've got to think about, what's your main target species, and if it's ryegrass, then you have to stick to certain other glyphosate products. But there's lots.
So I just interrupt. Am I clear that you're saying the 510 products are not as good on ryegrass?
Yeah, we've consistently seen that.
And that's ryegrass, not these weeds on the screen at the moment.
That is correct. Yeah, just on ryegrass. Yeah.
Thank you.
It's just a consistent message that we've seen. Okay, reputable products. It's not only the activity; they have other benefits as well. And here we can see we've got 2 products here. We've got glyphosate. It's a glyphosate plus trifluoro and tag mix. On the left, we've got Weedmaster Argo, and on the right-hand side is a low-quality product. And you can see that where I've circled it in white, there's significant sedimentation there, and that led to blocked nozzles. When the chemical rep there, David Keach, went to the property, the farmer was experiencing blocked nozzles, and the reason was because of that fact. So they did a quick test and identified that there was significant sedimentation occurring. So it's not only activity, but there are other benefits that certain products have. Temperature effects. Temperature is one of the most important factors for controlling or adjusting glyphosate. So the hotter it is, the less effect glyphosate has on our winter type weeds. So why the reason is, one of the main reasons is because you have more rapid dehydration of the product from the leaf surface, and then it's gone. It won't rehydrate. So we've done trials with wild oats, both in winter and summer, and pots were well watered. In summer, they were even kept in the shade house, well watered, so they weren't stressed. What we found that in summer, we couldn't control wild oats with 1.6 kilos active grams, 1,600 grams active of glyphosate, whereas the same population, same rates in winter, we killed them at rates well below the recommended field rate, which is in the red arrow. So a huge difference in efficacy. Even barnyard grass, which is a grass which grows in the northern summer states, even there, one of our PhD students, he was able to get better control at 20 degrees in a controlled experiment than at 30 degrees. So there are significant differences there. We see it all the time. We have to adjust our ryegrass rates depending if we're doing a trial over summer pot trials or winter pot trials to try and get the best effect that would be in the paddock at, say, autumn time. Because even in our trials, 1 litre of glyphosate in summer doesn't actually control susceptible ryegrass in some circumstances.
So, Pete, I'd looked into this a few years ago with the help of Dave Minke, who's done a lot of work in this area. And one of the things I remember him telling me was that when plants are growing in warm conditions, they have a thick cuticle. And then you might get those cooler conditions turn up and you think, right, I can go spraying. But the leaves still have a thick cuticle, and it's not until you get new leaf emergence in the cooler conditions that you can get the uptake. Would you agree with that?
We've seen quite a rapid turnaround in certain circumstances with control. So where we've done timing trials where we've had, and I did these trials last year during summer. I picked a certain week and a half period where we had hot weather, and I mean 38, 40 degree, and dropped to like mid to low 20s. And we were spraying at 2 or 3 day intervals. And what I found where I had the biggest change in control was where we had a hot day, and then the next day it cooled down. We got really good control of those ryegrass plants on that cool day. And it's like the plants went, oh, great, I've finally got some cool weather. Let me open up the windows and absorb the glyphosate. And it was really, really amazing. We got massive difference the day after the hot day when we applied glyphosate.
Yeah, right. Okay, well, that sort of disagrees with what I just said, but that is good news that we can that quick turnaround.
Yeah, it can be quite quick.
Yeah, great. While I'm speaking, just a reminder to everyone, get your questions in. Pete's here to answer your questions, so I'll keep an eye on that question and answer box. There's none there at the moment, so we'll let you keep going, Pete.
Okay, growth stage, effect, and herbicide rate. So here we've got 2 very important factors together, and this is some work that Tony Cook did in New South Wales, where he did some field trials on susceptible sow thistle and resistant sow thistle. And he did the trial on 3 different growth stages, so early rosette, early bolting, and mid-flowering. So increasing rates, and 2 different populations. And what he found that if you went on susceptible sow thistle, unless they got really, really big, like the blue line, you were able to get quite good control with sow thistle at the higher rates. At lower rates, you needed, if the plants were large, you needed higher rates to actually control them. But at high rates, it controlled everything. On glyphosate-resistant sow thistle, what he found was that at the early rosette stage, you could actually virtually kill glyphosate-resistant sow thistle with glyphosate if you timed it and got them at that very early rosette stage. However, once they started going into that bolting stage, you forget about it. You got very poor control. So message there, young plants are more sensitive, and even if they're resistant, if you come in very early, you can get very high levels of control compared to if you let them get a little bit bigger, then it's all over. So it's a very good message, that one.
Excellent. Thanks, Pete. Can I just stop you there for a moment? We just had a good comment come in from Mark Congreve about what we were talking about a moment ago in terms of temperature and the cuticle. Mark's comment was that plants dehydrate and rehydrate the cuticle based on the temperature to regulate their transpiration. So when the cuticle is dehydrated, glyphosate uptake is reduced as it's highly hydrophilic.
Yep.
Same for glyphosate. And so I think what he's saying there is that happens pretty quickly. And so that would explain your situation where you got a big improvement in control even just after one cool day, rehydrating the cuticle, allowing that faster glyphosate
Okay.
uptake.
Oh, thanks,
I
Mark.
haven't heard that before. Thank you, Mark. Another question come in from David. Is there any similarities between low UV or overcast conditions and then spraying on a sunny day as opposed to the hot weather? So I think what he's asking here is any difference in the amount of light rather than just the temperature?
I think it's humidity would be very important there. So if you've got bright sunny day, you've got very low humidity, whereas if it's overcast, you're most likely bound to have high humidity, and that will mean that the glyphosate will stay on the leaf surface for longer, and you'll get much better absorption.
Excellent. Thank you for that, and thanks for your questions and comments. Keep them coming, and I'll hand back to you, Pete.
Yep, thank you. This is some work that was done from in Western Australia through ICANN, where they took different water hardness and determined if they added ammonium sulfate, what would be the benefit. So they measured something called, where is it there, the ED50. So it's the concentration of herbicide required to reduce the control by 50%. So what they found was that at water hardness 32, so very soft water, you had no loss in efficacy at all. At water hardness 330, you needed a much higher rate to achieve that level of control, and you lost 74% efficacy. At 1,000 ppm, you needed 501 grams to produce the same effect as you had at 32 water hardness level. So loss of activity 86. And at 3,000, you needed a lot more glyphosate to actually do the job. When you added ammonium sulfate, then that vastly improved. So for 1,000 ppm, you only lost 10% efficacy versus 86% if the water was hard. And at 3,000 ppm, you lost 62% versus 90. So ammonium sulfate is very important. One of the factors it has got is to remove the calcium, magnesium, those cations, and let the glyphosate, dissolve a lot better. But it also has other benefits as well. So, but that means that adding the ammonium sulfate in the beginning, letting it do its job before you throw in the glyphosate, because if you haven't let it done its job, then if you bung everything together, then you're still going to have issues with the water hardness. And what I found out from this study too was that there are farmers in WA that have these portable desalination plants because they realise how important it is to have good quality water. So I've yet to see one, but yeah, it's amazing to know that there are quite a few growers in WA at least that have these portable desal plants.
Yeah, and the ammonium sulfate, Pete, I think is becoming very standard practice.
It should
be. A lot of farmers just say they just never apply glyphosate and some other herbicides for that matter without it. I think clethodim another one. Another question came in. I'm not sure if you're going to get to it later, but is there a glyphosate salt formulation that is the best one for knockdowns on ryegrass?
There are very good ones. There's not one. I can't say one is the best, but there's a whole group that are excellent. But one won't always be better. You do different trials, and you always get subtle differences. But all those the glyphosates that are produced by the high end chemical companies are all top notch ones. But there isn't one that's the best. So that's why I'm not naming any names. But all the ones that we know of, from the reputable companies, are all very good products, and they all do a great job. Some might do a better job under certain conditions, and others might do a better job under other conditions. That's why I can't claim that there's one that's the best, but all the latest ones are excellent products.
Can I put that another way then? Is there a glyphosate salt to avoid?
I think it's not the salt, Pete, and I'll mention that. It might be even
Okay.
the next
No
probably
worries.
the one after. Yeah, I'll go onto the salt one in probably the slide after this one. So the spray tank mixing order, as I mentioned earlier, you need a lot of water in there. You need to add your water conditioner and let it do its job, and then you start adding your herbicides in the order of granular first to dissolve, then liquids, then glyphosate, and then your adjuvants and wetters. So if you've got an oily suspension, then you throw in a liquid, a water soluble product like glyphosate, it's not going to work. So if you bung in your trifluralin, then you try and put in your glyphosate after, there can be issues there. So you've got to think of the order. So granular, liquid herbicides, your ECs, then your glyphosate, and then your adjuvants after. So don't put your soluble stuff before you put in your EC, SC type products as well. So just a bit of I've asked hundreds of farmers who fills a tank to 70%, and one farmer from the Wimmera said, yes, I do. So he proved me wrong that no one does it, but it's one farmer out of hundreds I've actually presented to. But if you fill it to 50%, it's pretty good. Salts and surfactants. So this is where we're going, Pete, and this is not my work. This is the work done by Andrew Somerville. And basically, salts don't improve the activity of glyphosate per se. They increase the concentration of glyphosate, so you need less glyphosate to carry around less glyphosate. But a high load glyphosate doesn't mean greater activity. It just means you need to carry around less. It's more concentrated. So it can be misleading. You think, oh, this one's a 570, this one's a 600. Oh, it must be better because it's got more glyphosate. No, because if you're using a lower concentration one, you're actually adding more glyphosate to the tank. But what the salts can do is they can improve the compatibility. We saw the trifluralin sedimenting out in the earlier slide. They can really improve that. And I'm not an expert in this area. So the thing that drives the activity of glyphosate is the surfactants. And surfactants range from really, really cheap palm oil type stuff to very complex blends of products. And you can bet your bottom dollar that the glyphosates that are really cheap have got really cheap surfactants. Those really low quality glyphosates. Should be careful not say cheap, because there are some good glyphosates that aren't, not overly expensive. But a lot of the low quality glyphosates are often the ones that have very poor surfactants, and also dodgy amounts of glyphosate as well. I've heard some guys saying that if you want to order a glyphosate from overseas, they ask you, do you want the high load, the medium load, or the low load? And depending what you choose determines the final price you get. So if you get the low load, it means that it's sublethal or suboptimum to what should be in that product. So that's something to remember. It's the surfactant load, and a lot of the companies now are not putting in just one surfactant, but putting in blends of surfactants to really drive and maximize the efficacy. And it can differ. Certain surfactants are very different. They have different properties. Some work better on some species than other species as well. So you've got to think of what your target species is. So just to summarize that up, there are 4 or 5 factors that are important. Use the best products, use the high label rates, spray younger weeds and non-stressed weeds, and don't spray under stress conditions. The bottom 2 factors are not under your control. You can't control that. That's based on the climate, the weather. But the top ones are under your control. So if you maximize those, then if you have some stress in there, you can avoid reduced control because of those stress conditions. And just think that I'm using a really good glyphosate. It's the most expensive one, so I can be tardy about it. And no, you have to think of all those other reasons, all those other factors, optimize those so your glyphosate works the best. So good quality product, good brand, there's no substitute for poor application. You have to optimize the application as well. And that's how you get an excellent control. So yeah, here we've got a fence line trial that we did a few years ago. And what we saw there, the front one there is 2 litres of Roundup Power Max at that stage, had no effect at all, but there was a lot of treatments in there which worked really well. When we moved, we also measured ryegrass from the fence line perpendicular to the crop and identified that the further you went out, the better, the lower the level of control, the lower the concentration of glyphosate products, of glyphosate resistant ryegrass. So the glyphosate resistance started from the fence line and was moving out into the paddock. There was a concentration gradient, less survival of ryegrass as you moved away from that fence line. So it moves. It moves by pollen, it moves by seed, by machinery, by the harvesting operation and the sowing operation. If you've got glyphosate resistant ryegrass, can you crop top with glyphosate? Will it work? And the answer is no. Glyphosate resistant ryegrass has glyphosate resistant pollen, and that pollen is not controlled by glyphosate. So if you have a paddock, a mixed susceptible and resistant plants, and you spray at the optimum timing, you will sterilize the susceptible plants, leave resistant ones behind, and then they will preferentially cross-pollinate, and you can actually fast-track resistance. So you've got to be careful about that too. Bit scary that one. Double knock. When do you double knock? If you're doing a double knock, there was a lot of opportunities for double knock this year, and a lot of them were done. Put out your glyphosate. So the theory there is to try and kill any glyphosate-resistant plants. So you spray your glyphosate, kill susceptible ryegrass, kill other species. Resistant plants won't be killed, but glyphosate still stresses them out. So resistant plants are still stressed by glyphosate. What we found, and this is some work that Chris Preston did, was that within 5 days, he got complete control of not only the susceptible ryegrass, but also the 2 glyphosate resistant ryegrass populations when he sprayed between that 1 and 5 day period. After the 5 day period, he started to see survival of the 2 resistant populations, but not the susceptible. The susceptible was killed, whether he sprayed the paraquat 1 to 5 days or 7 days or 12 days later, 10 days later, he still got control. But the resistant one survived, and the reason is because glyphosate was stressing them out, and then paraquat was not being absorbed as it should have been. So that's the theory there.
Was that done a bit of a marginal paraquat rate, or was that a robust paraquat?
No, that was robust. That was field rate.
Right. Okay.
Yeah, field rate. So that's the issue there. Now, if you've done a resistance test and you've got lots of glyphosate resistant in the paddock, it might be worth considering double knocking with paraquat if the first application of paraquat doesn't do the job. And in that case, you actually have to change that timing, spray the first application, and then wait for that if any ryegrass is going to survive, based on if it's a big plant, or we're not talking about resistance here, we're talking about big plants, then with paraquat, you want to let it regrow, young fresh foliage, and spray it again. And that usually takes 2 to 3 weeks. So that's different if you're doing a paraquat followed by paraquat. But glyphosate paraquat, 1 to 5 days. This is a photo I got a couple of days ago from Greg Sefton from Sefton Agronomics. He showed in this situation here, he had lots of the sprayed early southern New South Wales. Glyphosate went out and it was dog's breakfast. This is an 8 hectare area section. They just bombed it out with paraquat to sort out the problem. So it's caused a significant yield reduction there, or there'll be less yield from that paddock. That's 8 hectares. Very competitive situation there. A good crop this year, but as they've come in and just bombed it out, that particular strip, they believe that a lot of this ryegrass has come in from floods, from irrigation. And, if you think about where a lot of glyphosate's used, it's used along channel banks, along non-cropped areas. So that's where you start to get resistance building up, fence lines, all those areas there. So if you get water moving from those areas, moving seed into the paddock, then that's what you can see. So
another question in here, and pretty vivid photo there. There's some big nasty ryegrass there. I can see why they bombed that paddock out. The question is from Roberto: if selection drives resistance, what do you think about paraquat followed by paraquat for a double knock strategy?
Yeah. The only place we've ever used that was in a fence line situation where we're just doing a demonstration where it was springtime. We had plants that were large. They were, almost up to my waist. We couldn't see the ground, so we had 2,000 seedlings per square meter to start with at the beginning of the season. So we had a wall of ryegrass. We sprayed paraquat, and then we came back and sprayed paraquat 2 weeks later, where we had just a little bit of reshooting because we'd done a 99% job the first application, and that just took it out. So that's what I was referring to there. It's definitely not. Don't recommend double knocking with paraquat doing large paddocks with it, because we are starting to see, I haven't got it here, but we are starting to see some ryegrass, which I believe is, we're doing more trials, but we reckon we've got about 4 or 5 ryegrass that are paraquat resistant already. And this is not from fence lines, but from within paddocks. So we're just going to do a little bit more verification to prove it, but they're looking pretty suspicious at the moment. So we are, we don't want to over-rely on paraquat. So Roberta's spot on. I wouldn't be recommending paraquat followed by paraquat as a double knock because it can be, you don't want to kill the product.
I know that you're saying the right thing, and we don't want to over-rely on paraquat, but I'm actually okay with a bit of paraquat followed by paraquat. We've got a lot of situations where we just have to get a knockdown, and if you've got glyphosate resistance like that paddock there, that would have been better with the double paraquat before seeding, and then looking to smash the seed bank and get rid of that whole seed bank. So I know that we probably shouldn't say that, but we know that we've had a lot of years of just glyphosate on its own to develop glyphosate resistance. I know that we don't want to just rely on double paraquat forever, but it is a very useful tool in the short term, and then allow us to smash the seed bank. So might be the wrong thing to say, but I think sometimes we just have to do what we have to do.
On large plants, if you don't get coverage and you get rapid effects, then you won't kill the plant because there's a lot of resources below. So a second application will just kill that, will finish that plant. So it's not resistance, you're not selecting for resistance, you're just finishing that plant off.
Yeah. Okay, but we've gone for quite a while, 45 minutes. I'm not sure how many slides you got left, but if
we can just, that's okay. Just to basically say that if you've got any issues with, you suspect any resistance, then like in that slide there, then we can, even if plants are large, we can still sort them out and do a glyphosate resistance test just so you're sure about what's happening. If you've got glyphosate resistance, or if you haven't, and maybe there's another factor there. So you think you've got glyphosate resistance, however, there was some other reason that ryegrass survived, and it wasn't due to glyphosate resistance. So testing is possible. I can leave it there. I'm happy to leave it there.
Thanks, Pete. That's been really great. We probably went a little bit longer than we planned, but I think the information was so good, I didn't want to slow you down. So I really enjoyed that. If there are any more questions, please put them straight in the question and answer box right now. I guess let's just summarise all of that. We want small weeds, good conditions. You're saying coarse droplets better, and 80 litres of water is around optimal.
Yep.
We're also saying good surfactant package. Now, my question to you is a bit smoke and mirrors around surfactants. I don't think the companies have to declare exactly which surfactant they have in fully loaded glyphosates. Have you got any advice other than just sticking with a reputable company that you know, but have you got any advice on how to pick that right surfactant?
No, not really.
Yeah.
Surfactants are just such a complex group of chemistries. It's not like saying two group A herbicides, diclofop and flazofop, for example, fusilated and high-grass. Surfactants there's a lot of variance, and there's no real way, unless you've got a PhD in chemistry, you have no idea what's going on.
Yeah. Okay. So really, it's just about sticking with the reputable companies that you're familiar with, and getting to know the right product. Now, when you said 510 glyphosates, I'm guessing there's a few of those on the market. Any thoughts as to why you think that you're seeing some problems with them?
Say that again, Pete.
The 510 glyphosates.
I think they are all a certain salt as well,
Right.
and so that based on that, and probably you can only load certain surfactants, I guess, in with certain salts. So that combination there is just not. You have to use higher rates to get the same equivalent, the same control.
Okay.
I'm not a chemist, Pete.
No, that's okay. I was just
Yeah.
something that really stood out to me in your presentation today. I hadn't heard that before, and Now, look, I've tried to sum it up there. Have I missed anything in that summary?
No, you're spot on, actually.
Okay. Yeah, and the double knock was the other one. Get that second knock on within that 5-day period is optimal as well.
Yep.
Okay, I think we have another question here or a comment. Are the 510s isopropylamine salt?
Yep, that's right.
They are.
Yes.
Okay. So the IPA salt on the 510s. Okay. Well, that might be a subject for further investigation, I'm sure, and someone from the companies might be able to shed a little bit more light on it for us as well. They are the chemists, and they might have a greater understanding.
Yeah.
Well, thanks very much for your presentation today, Pete. I really enjoyed it. I learnt a lot, and we appreciate you giving up your time and putting it in. Well, we might have. Oh, okay. Careful. There are also some 450 IPAs as well, apparently.
Yeah.
Okay. We do need to be careful. We probably shouldn't generalise, but.
Look, I can spend all year just testing glyphosates and getting results. That's how many there are and how many combinations you do. So it's just there's just a few generalisations we've made, but to actually have 100% knowledge, you have to do. I could spend all year just testing glyphosates on ryegrass to try to create a better picture, because I always get asked, is this glyphosate better than that one? And it's like, don't know.
It could be a future career option for you, Pete. I think we would do that.
No, thanks.
No problem. Okay, well, thanks everyone for joining us, and thanks Peter Boutsalis for your time. This has been another great Weed Smart webinar, and we'll keep coming, particularly during this year of COVID-19, because we can't get out in person, and so this is a great way of people like Peter sharing their knowledge with everyone. So thank you, Pete, and thanks everyone for your time, and look forward to seeing you in the next webinar.
Good. Thanks, everyone. Bye.